This question is on Newton's third law, and we'll be using the exact same technique for us to identify the pair forces very easily. So let's get right to it. First up, I will focus on the vertical forces, and there are many answers here, actually many pair forces here. I will use one example of pair force to show you how to use the technique. So very common vertical force acting on objects on Earth must be the weight of the object. So I'm looking at just the sleigh itself. So there's this downwards weight acting on the sleigh, and what causes gravitational force or weight? It must be the Earth. Remember, in Newton's third law question, to find paired forces, you must label these forces accurately with the two objects involved. So this is the downward force, which is weight, acting on the sleigh caused by the Earth. And the second step in finding pair forces is to always just reverse the arrow. So it's an upwards arrow, equal and opposite force, and swap the objects. So just now on the sleigh itself, the label is weight on sleigh by Earth. We just need to swap the order of these objects, and the pair force is therefore now weight on Earth by sleigh. So there you go. We have now figured out one pair of forces. Okay, so a second force that acts on the sleigh is the blue force, drawn in blue, which is the normal contact force. This is the normal contact force that supports the sleigh. So it's acting on the sleigh, supporting the sleigh, and it is caused by the ground. So I've labeled it accordingly. And same technique, reverse the direction of the arrow and then swap the objects. And with this, I will draw a downward arrow and I swap the objects. It will be, instead of on sleigh by ground, it will now be on ground by sleigh. So therefore, the object will be on the ground itself. And there you go, we have now identified two pair of forces. There are actually, you can actually repeat this on the horse itself. So it's exactly the same technique. Instead of looking at the sleigh, you just look at the horse, and you have the same two other pairs of vertical forces. Okay, moving on, we can also apply the same technique to find pair forces in the horizontal direction. So let's just start with one of the force, which is the pulling force by the horse on the sleigh. Again, I reiterate, it's important to label the force with the two objects involved, because in the next steps you will reverse the arrow direction and you will also swap the objects in your label. So by doing that, you realize that the pair force is a pulling force on the horse itself by the sleigh. So this is one pair of forces. Now, there is a second pair of forces that we can find. So when the horse wants to move forward, it must dig its leg backwards. So the horse is pushing on the ground backwards. If you are the ground, you will feel that the horse is pushing you backwards. Okay, so I've drawn this backwards force, a frictional force acting on the ground by the hooves of a horse. So that is in blue. The same technique applies. Reverse the direction of the vector and swap the objects. So forward, we're looking at a forward force, and when you swap the objects, we realize that the ground is pushing back onto the horse and pushing the horse forward. So that's the reason why when we kick back on the ground pushes us forward and we can move forward. So this is a second pair of forces. A third pair of forces, now as the sleigh is being dragged along the ground, forward, and therefore on the sleigh itself, there is a frictional force that opposes this motion, that is backwards. I've drawn it in orange. Same thing, reverse the arrow direction, swap the objects to get a forward force on the ground, and it's acting on the ground by the slate. So this one needs to change. This one should be acting on the ground by the slate. Okay, so these are three pairs of horizontal forces. The last part of the question is a question on free body diagram. So a free body diagram shows all the forces acting on the object. So in this case, the object that we are focusing on is the sleigh. So I've drawn a sleigh here, and there should be a forward force, and this is a tension force of the rope, or it's a pulling force by the horse on the sleigh. There's this normal reaction force. Sometimes we call it normal contact force also, and it's an outwards force that is exerted by the ground on the sleigh itself to support the object. There is a frictional force as the sleigh is dragged forward. The frictional force acts in the opposite direction, which is backwards, and of course there must be a downwards weight acting on the object.